Hello, can you hear me now? Hello?
Yes, yes.
I think that I shut down the meeting occasionally at the beginning when we went for break. So, as promised, now we will go to the survival analysis. Sorry, I think you was dropping the. Oh, can you see my screen right now?
Yes.
Yeah, so first of all, questions and questions, concerns, suggestions by now, if you can align before we go there.
Everything good from my side.
Saman and all actively commenting. Other guys on the call. Okay, Andel, yes, all good. Okay, I hope all good. Okay. So let's start with the survival analysis. So anyone have heard this expression so far? Survival analysis? Or anyhow face this field?
Is it about the airplane who gets shot, or it's different with survival bias?
Airplane? I'm not sure. I'm not aware of this example. Can you explain more?
No, I mean, just like not to confuse between survival analysis and survival bias. So there was like a time in the World War about the airplane who always get back. They always get shot in some certain area.
Mm-hmm.
So they try to build a defense around that area, which apparently they didn't cover one part because those planes who never get back actually get shot in that particular part.
I think it's actually different, but I may be mistaken. I haven't heard about it. Yeah, the survival analysis, it comes from the word survive, and it sounds like such a dramatic, exactly because it's actually was originally created for a purpose of medicine. So statistics and data analysis has a long tradition with analyzing medical data. And right now also a lot of data scientists invest efforts and time in the medical technology, biotechnology. Right now I work on one publication jointly with one Ukrainian startup in the bioinformatics field, and I found out that I have no idea about medicine or no idea about biology and about genome structure. But as I figure out, like a lot of knowledge I have from a data science is highly applicable for medicines. And at the same time, a lot of methods which are originally created for a medical application found its application in other fields, like for example, in customer analytics as a survival. So let's get aligned. I told that first of all, we think about our customers from transaction perspective. And let's look on the customer one by one. Well, if you look in the data in the history, what we will see is that like customer number one did one transaction, customer number two did second transaction, third, fourth, fifth, and so on. Then we see some number of transactions from customer number two, then some transaction from customer number three, and some transaction from customer number four. It doesn't tell us some significant story. So second thing, what we do, we in our assumptions, we say, okay, there is a life cycle. It has an end and it has a beginning. So a life cycle started here, finished here, started here, finished here, started here, finished here, or didn't finish here. And this one started here and like going on. This big solid gray line is a line for now, right now. So we don't know what happens next. We just know that we had these transactions from customers in the past. So what about this customer number one? You see, it can be either green or red. We don't really know was his transaction, was it the last transaction or it wasn't really last transaction? It seems like from his life duration that it probably was the last transaction, but this period of time still didn't pass after it was last transaction. So we cannot be confident, was it last or wasn't it last? If you look on the data from like this, just on sum of transactions, it doesn't tell us anything. It was last transaction happening yesterday. It could be the last one, but we don't know. So the basic idea of the survival analysis is to understand how often people leave given some conditions, or how often does this customer leave, what's the length of this lifetime between start and the finish. And so what we how we can transform this data, we can take all the duration of all the lifetimes of all customers and build such a simple line where on the X-ray x-axis we will see it's a medical topic, so I said X-ray instead of x-axis. So on the x-axis we see a time which passed since the beginning till the end of the life. On the y-axis we see a probability to survive. Let's start with the example of people's lives. Yeah, so this time is age of people, right? What is the probability to survive if you already reach 80, or not like this? Let's say this is a childhood. There is some children mortality at the beginning. So out of 100 children, only some 90% actually survive the childhood. And then there is some middle time. There is some people who like only 70% of people survive till, I know, your senior age. Then till your 90, only 10% of people are surviving. So this percentage of people who actually survive is decreasing. And then let's say this is the age 100 plus, when the probability of surviving is super small, because like very few people actually manage to live till 100 years. So all the idea of survival analysis is that we are able to model the customer lifetime or customer life cycle duration as a dependency between time he's alive and this and this probability of him to be surviving. And let's say, let me give a more specific example here, the intuition behind the approach. So if we take the probability that some random customer here will be still a customer after 4 weeks from his start is only 35%. And expected average time alive for all users, like here, was like just 3.5 weeks. So it's average. But we see that at least 35% of users here are still alive after 4th week. So question, what if this line, this dashed line, would be much higher? Is it good or bad?
Good, of course.
Good, because more customers are surviving longer time. If this line would be actually closer to this lower level, it would mean that more people are dying during, or more customers are not surviving the customer survival period. If we take, let's say, some distinctive feature about customers, this specific example comes from the e-commerce, where there was number of views based on how many views people actually do daily in average to the web page, how they are surviving. So you see that actually in this case that we see that first of all, the input information that 50% of users made only less than 20 views to the platform. And then we see that customers who generate 200 views, their survival is the longest, so the line is the highest. Then people who generate 5 views a day, their line is actually the lowest, which is making sense, right? So like the more views you do, that like the more active customer you are, so this is your life duration. It is possible. So that's the basic idea of the survival analysis. We try to build this line is called a survival function. And we try to model that survival function for each specific customer. Yeah, this is like just detalization of the same visual that this top line is most active customers, and their expected life duration is 4 weeks. The customers which are like the lowest level, the blue one is 20 views. Their expected life duration is only 1 week. So how can we model this kind of situation? Well, we can define so-called survival function as survival as a function of time, as a probability that event of interest, in our cases the churn event, has not occurred at time t, and or didn't. So if we go back to here, we see that for this customer at, let's say, I'm not sure what is this. This is the week. This is the weeks. Yes, this is the weeks or days. Let's say days. So that by day 12, after he became a customer, the probability that he didn't die is 40%. by this given moment. If some of you studied statistics in your background, you may guess that this is the opposite of cumulative distribution function of life duration. So in statistics, most of these distributions which I show you, distribution chart, this is called probability distribution function, or PDF. Then there is a cumulative version of that function. It's called CDF, cumulative distribution function. And then this one, so for those with the math and statistics background, this is like 1 minus CDF, and CDF of a lifetime duration. Important to say that this function is non-increasing. It will be always either flat or decreasing. Again, for the statistics background or math background people, CDF cannot be declining. That's why 1 minus CDF cannot be increasing. Similar to the survival function, we either, like with the time, the probability of surviving cannot increase. The longer people live, the more probability to die. Yeah, this all puts on us one big assumption to customer analytics, that people actually, for sure, they will stop using the service. That like lifetime has a beginning and the end. So we should make sure that like we can really make this assumption that people on some point for sure stop. It has the end. I mean, if you model it as a life of people, of course people die in the end. I mean, all people die in the end, and like they cannot stay customers forever. But there are services where like within a year or within a couple of years, people don't change the service. For example, utilities, right? People don't stop using utilities. Like people pay for electricity and for water all their life. And so we need to make sure that we can clearly define the end of the life of the customer, and it happens for sure. Second part is important definition is called so-called hazard function. The hazard function is a probability that there will be the event of interest within some small period of time. So it's basically something similar to derivative of our derivative of survival function with respect to time. So it is, if we go back to our chart, is a probability that that event will happen exactly on some point of time. So if hazard shows us that probability that event didn't happen so far, so if survival function shows the probability that the event didn't happen so far, the hazard function show us that the probability that event will happen exactly within some small period of time here. It's actually not a probability, but the index, because important to say the hazard function is not a probability. Because hazard function can be by definition bigger than 1. So it's not exactly a probability, but it is like mathematically it can be less than 1. But if we take the unit of time, let's say 1, on delta time is equal to 1. So this is a change of the probability of survival within some small period of time. So that differences in probability of survival before and after within small period of time. I'll just explain why we need to align on this definition. And as I told, so if we take this probability or life duration distribution, probability to survive within life duration, and we take some small delta time t, so that will be, this area will be our hazard function. Don't fall asleep right now. We are getting to the point. So there are two important methods which we apply in order to analyze the customer churn. One is the easy one, and it's called Kaplan-Meier estimator. If you are interested, there is also links for papers with original methods everywhere. As you see, it was developed in 50s in Stanford. So pretty old method, but it's also super easy. So Kaplan-Meier is suggesting to model a survival curve as a probability of surviving given the length of the time considered in a very small intervals. How does it look? So basically, we aggregate all our data by very small intervals of time and check how the probability of surviving. So here's like this is already a different data from another e-commerce, but the function is exactly the same. So we see that this line is smoothly declining, and we see that like after 4 years, no customer is actually a customer. We can also visualize it based on, let's say, male, female. In this specific case, there is no significant difference between male and female users. But we can visualize it based on the different categories. What's important? In this data, or in the survival analysis in general, we don't consider a live customer at all. We take only those who died for sure. So we take all customers who were dying in the past and check how they were dying, how fast they were dying, depending on the time. This allows us to solve this problem with the data censorship, because we don't consider those doubtful clients. We consider only those clients who actually started his life, died for sure. We are super confident about them, so we know. This puts a challenge because it's a purely historical data on the other hand, and we should be able that based on this historical data, we should be able to make a conclusion based on about the future data. Any questions so far? Hey, can you hear me again?
Yes.
Yeah, sorry, my computer was disconnected for a second, so it's went a bit offline. But I think you had the time to think about the questions about the survival analysis. I see two comments that all good, all clear, right? Okay, so this is easy part. We call this method relatively easy. And we call it non-parametric, which means that like we basically don't consider impact of some other factors and so on. We can just take a data, show its distribution, how it was looking, and we can understand how people were dying. But what's important is the next step. Is another method which is called Cox proportional hazard model. We call it semi-parametric, and it reminds regressions if you know it. So it's pretty similar to like regression style, like which you probably had in other courses. So the difference is that in this Cox proportional hazard model, we dependent variable is a hazard function. So our y is a hazard function, which I was specifying. And then we can put a lot of independent variables. So basically, maybe you will just need to pay attention on this formula number 1, or first formula, where we model hazard function at the given moment as a multiplication of e in the power of sum of our coefficients and factors, or x's. And then we have this h, so the hazard function is ht. And then we have this function called h0t, which is our baseline hazard function. So basically, what we are trying to understand, how much our life duration was deviating from baseline, from average, given different factors. And this baseline hazard function is something very similar to Kaplan-Meier estimator, but it is exactly equal. It is equal to hazard function as if all the other factors were used for were 0. So all x's are 0, then we have a baseline. I will skip this a little bit to technical derivation of coefficients, and let's go to the function itself. So let's go back to our function. And so we see a survival probability based on the Cox regression. So what we get here is, first of all, we get the hazard function itself. And we get these boundaries, which is like confidence interval for this hazard function. So like we say that hazard function is somewhere here in average, but for sure it is within this interval. For sure, I think here we talk about with a 95% confidence, it is within this interval. Yeah. Interpretation of the Cox proportional hazard model. And now we will switch to notebooks, and it will be insightful, I think, from a notebooks. How do we apply it? So important thing and important benefit, the Cox proportional hazard model, we can build as a regression. We can have a coefficient, we can have multiple factors. Basically, it works exactly the same way as a regression with MLE estimator. So it's not like OLS regression, which is like more popular, but it's like similar in estimation, like as it is in the logistic regression, for example. So how do we interpret it? So we get those coefficients betas in those regression. We will now see them. And if that beta is greater than 0, or it means that like our hazard is deviating positively, right? and it means that our probability of surviving is increasing, which means that it's good for churn. I mean, churn is decreasing. And vice versa, if that coefficient is negative, we are decreasing, we are deviating down from our hazard function. And it means that our probability of churn is increasing. So like the bigger is the coefficients we get in this regression or Cox proportional hazard regression, this the more we deviate, the more some conclusion we can make about the impact of some specific factor. So this is a theory mass part. I think we will switch at the given moment to a notebook with this available for you in this in the folder. So, but before we go there, is everything clear with this modeling, with this model, survival model? Yep.
In general, yes, yeah, but maybe to be honest, I couldn't follow the details with the hazard function. Yeah, so
okay, I will a little bit come back to this.
It needs maybe
Yeah,
just some extra time to go.
It needs time to understand and to realize, and maybe
yeah.
more important to understand the applicability, because it's really heavily loaded of math, and actually the question is what to do with those who are dying in the short term, and can we return them back, or what techniques can we apply in a business terms to how to say, to affect the model, to change the coefficients, and to obtain a better picture of our churn.
Yeah, I will show it to you now. Of course, this was the math part, and this is the theory part. Now we are switching to practice. I know that it takes time to like get used to this perceptions. That's why just take your time, like try to read it by tomorrow from the slides. There are also links within the slides where you can deep dive into more details. And just feel free to come up. We can start tomorrow with a question session. Now we can go to the practical part, and I will try to answer the questions you asked, okay? So we go to notebooks. Here is like you go churn online. Oh. Okay, actually I realized that I didn't place a notebook to you. Just let me send it to you for a second. First, I will share it. So here is a notebook share, and then I will just spend a second to locate it in the correct folder. Yeah, so now you see this notebook in. Now you see this notebook in the correct folder. Can you all of you see my screen well? Yep.
Yes.
Cool. So this is a pretty short notebook. Let's go step by step together, and then you will be able to play with it by yourself, or you actually can copy and try to run it by yourself. So first, what we do is everywhere we load the libraries and packages needed for it. Somewhere I also have the R version actually, but I realize that it's not that popular these days anymore. So then we load the data. So the data is actually now uploaded to my GitHub account. So it just links directly from my GitHub account. It's publicly accessible. So we loaded the data from 3 different data sources. So one is products, second is transaction, third one is users. So let's look one by one. So we put a products head. It's a very easy, so it's like ID of the product and ID of the product category. Some categorization of product, fully anonymized. Second one is transactions. So we see the ID of transactions, ID of user, transaction time. As you can see, the data is actually pretty old already, but it was like 5-year history. I don't know. And ID of the product and the price, which was paid. So again, pretty easy, like this kind of data available everywhere, just price, transaction time, and so on. Then we check users, which information we have about users, ID of user, gender, and age. In some cases, age is unknown, and some cases, gender is unknown, which is like pretty typical for a real life. So first of all, what we should do, we just do some data pre-processing. So now just checking the size of the data, format of the data. That's maybe something what we can run very fastly. Adjusting the format, that time is actually a time here. Then we can try some little aggregation and see what was, which user was, like by user, we just check which product he was buying. So for example, this user was buying like a few products in different times between 2014 and 2015. And so this is like all, he bought just one quantity on the different prices. And so that was his total income. We can make it for more users, just put head 100. Okay, it doesn't display anyway more on the screen. But yeah, we can see that some users buy 2 items of the product, but usually they buy just different products and so on. So then we do some pre-processing of transactions to just align the data formats and so on. So nothing specific. So we see that like in this online store, the transactions were growing, like the amount of transactions were growing a lot in the day-over-day basis and reaching a maximum. This is like randomly picked transaction, so the amount of data is not that big for simplicity. And then this is like not the drop, but this is exactly the data truncation here. So we see some data didn't finish, and that's why it seems like it's our data censorship. And some data didn't finish, so actually it seems like it decreased. So let's move on to check with how the average price was developing for how much people were buying, and we see that okay, like I think in this specific case the currency is Czech crown, so it's approximately $200, and we see that okay, at the beginning there was some strange fluctuations because of the amount of data was small, but then the average price was smoothly growing to somewhere like $300, which is like around 7,000 Czech crowns. Well, first of all, what we can see, like inside number one, the data generally has a big seasonality, right? So there is like moving up and down, and so on. That's usually from data perspective, it's called seasonality. It's useful to know that we have a seasonality because then we can make sure that some impact of some factors is the impact of seasonality and not impact of the factors itself. So it may be just some factors may be just also correlated with seasonality. Okay, then we pre-process the user data. So all this about just to check the size of the data and so on. We see that pretty significant amount of genders we are unknowns, like male, female split. There are more females than male, but then there are a lot of users which don't indicate the gender anyhow, so we don't know. And then age groups. We have this age group which is like below 18, which is pretty small. This is like pretty nicely normal distributed because we see that, okay, there are biggest amount of customers are between 19 and 35, and then a bit higher age customers are small, so most of customers are actually here. And so it just like so far it's just still just some review of data. We did some gender mapping here just to fix this problem of mapping. So we basically applied some very easy technique to assume it's similar to clusterization. We just assume that the most of user have some user which is actually behaving similar way. So based on the similarity, we assign this, and based on behavior and similarity, we assign the gender. So we kind of fix this problem is a large number of unknown customers by assuming that the unknowns are more or less the same distributed as customers. And then what else? So we see that how price is actually differing by age of the, how price was differing by the age group. So a couple of standard insights which you will be able to produce every time for every single analysis, just some summaries. And so we see that like for in terms of activity, young people, people in the young age is the most active, both in terms of volumes and number of transactions. But we see that in terms of prices, this is pretty much the same average price. So no significant difference or some dependency in age. Okay, now we go final to the churn analysis. We need just to install this library, which is called Lifelines for churn analysis. From Lifelines, we import two methods, Kaplan-Meier estimator, which I just mentioned, and Cox proportional hazard model. Let's review the data which we prepared for the analysis. So the data is already merged data in general, which include on the granularity of the transaction. So we have ID of transaction, ID of user, transaction time, ID of product, price, year of transaction, month of transaction, day of the month, week, day. So this is all data is possible to extract from a date. Then gender, male, female, age, age group. We created these categories for the age groups. And then ID of the product category and gender in a more or less numeric format. Then we generate the churn column, whether the churn or data frame which is useful for churn. And then again, we see that just filter out like not that only the useful part of the data for us. And next one, what we are trying to create is this time to event. So time to event from the first transaction till the last transaction, or time to event from first transaction till the maximum time we have. So we regenerate this churn value, and let's look on our data frame here. So we labeled whether customer was churned or not, and how much time between the either start and end date of the first transaction and the last transaction, how much time did it pass? And if it's like not churn, this is the time between the first transaction and the, let's say, current time, more or less. So let's first of all review with the same method Kaplan-Meier estimator. Oh, sorry, we should also durations. So let's then review a Kaplan-Meier estimators. So what we see from Kaplan-Meier estimator is that, like, okay, as we expected, the users are dying with time to sorry. So users are dying with time, and like up to 1 and 4 years, only something like a 5% of users actually stay as a users. And we can try to generate the same cars for each cohort individually. So for example, for male and female, again, not a significant difference for this definition. But we see that, okay, male were churning a little bit more actively in this data, right? Then we can try to generate the same survival or churn by different age groups. So what we can see is that, okay, the people who were like, even though we had a lot of people in the age of 1935, we see that actually they were churning the best, and then the customers who were 46 plus, they're actually super strong against churn. So we see that their survival function is like the highest in most cases. Yeah.
And
question?
how can we, let's say, use it on our benefit?
For example, you can design a campaigns for like, you know, that okay, you have
40 plus.
I mean, not for 40 plus, but I mean that, you know, that those people who are in the age 1925, you have a lot of them. They are very active in the platform. At the same time, they're churning. So you can make some retention campaigns for this group of customer. So far, this is like only based on the groups. But if we go further, for example, we defined this Cox proportional hazard model. Okay, we just rerun everything. Oh, skip this part. So first of all, we get some regression style output here. So we are able to see which factors positively or negatively impacting the hazard function and this probability to survive. So we get here the coefficient. Is it like positive or negative? Then we get a confidence interval for coefficient, z-score, and p-value. I guess that's okay. In this specific case, p-values actually are pretty huge, so we cannot make a very easy conclusion about the impact of those factors. But if, for example, you do the same, like for example, sometimes we design experiments, right? So we say that sometimes we design the experiments and we say that okay, we pick those customers and for those we could give a campaign, for those people we don't give a campaign, and then we try to check how did it impact churn. So like, for example, you can set up this model, you can then apply some campaign and measure how did it actually impact or did not impact your churn. If we continue running these notebooks, we can see that it's also possible to predict a churn probability on some very individual level. So this is like for a few randomly selected users. We see that, okay, some user was like, had the highest probability to churn, and some user had the lowest probability to churn and highest probability of retention. So what you can do, you can, for example, you see this category of people, right? They are not that, like, they are not churning that much in this period. So first 3 years here, they are churning very little, right? And then we see that they sharply increase the probability of churn in this period, right? Or like this, like one very specific person. So for this specific person, we know that before he was more or less stable customer, like churn, like with his churn like above average, or his retention behavior above average. But now we see that if we are at the given point of time, we know that he can have a sharp decrease in this churn probability. So what you do, you filter out all users like this, and you give them a retention campaign. Of course, retention campaign is not going to save all of your customers, but like in practice, it saves like significant amount of customers. Like in this example, the banking product I was showing, it was saving up to 30% of the customers, which is actually a lot if in the total terms. Yeah. Any questions to me? This is like bad sign. If it's like no question, it means like nothing is clear. Name transaction is not defined. Carello, I think you should rerun this part.
Yeah, I already tried, and on each particular piece of code, I have the same error. The name of the, let's say, cell or the subject is not defined.
Can you make sure that you rerun this cell number 2?
Cell number 2.
The one which I'm sharing right now on the screen. Maybe you typed and occasionally change the name of this row.
Yeah, I have the same error. Name PD is not defined.
Did you run this one?
Just a second, I'm switching between the screens.
So PD is the name of the data frame pandas. So you should run.
Okay, let me try again. Okay, looks like everything. Yeah, now it works. Thank you.
No problem. So I am mostly done with the all content I prepared for today. I think we are a little bit above time, so I suggest we first of all run a discussion table, and secondly discuss a little bit your homework, which you will have to. So far it will be about segmentation. So let's start with the round table. So the questions.
Yeah, may I start with the technical one? So we have this kind of template, yeah, and talking about data. For instance, I have some data array. How I can connect this template with that data? How I should technically,
Data transform. You mean how to do a data transformation to this format?
For instance, yeah.
Yeah. Well, there are a couple of different technologies. How can you do a data transformations? Most often, what I use is SQL. It's the most popular one. But you also can do a data transformation within Python. So you can just upload your data to Python, Google some functions from Pandas about data transformation, and do it. You can also do it manually in Excel if its data is small enough for Excel, and then load it to Python. Maybe, yeah, I would for sure recommend to learn basic of SQL. It will gives you the biggest ability to manipulate data. And actually, you can also run SQL functions within Python. So, like theoretically, here you can transform everything within the same notebook. I mean, we can also do it in R. You can do all different versions of SQL. Yeah. And at the same time, I don't think you should think that you should follow exactly the same template. What's important that you follow the same format of modeling events. So you should have time to event, and then what you plug into this churn analysis. Where is it? My Cox regression. Yeah. So eventually what you are given to the Cox regression is basically, sorry, where is it? You need to give this time to event and event model and then features. So in whatever format you have, like what you really need to insert is it churn or not? And what was the time to this churn between start and the end? All other data you can prepare as you wish. I mean, or as your data allows you. Any other questions, Kirill?
No, thank you. I'm good. I'm just thinking how I can apply all of these things because I'm not a math person, and for me, it would be easy to, just purely mechanically run this script again and again. to understand the essence of the
Yeah.
After that, try to elaborate more on the SQL and other kind of stuff. So it's really interesting as for me.
Yeah, you may skip like all this data pre-processing you can do in Excel if you prefer, right? If you, the most important that you, for each user, you say is churn or is not churn, what was the time to churn? The model, you just can plug it mechanically. Some other questions, guys? I can see only Ari, Simeon, Kirilo, and me are still using cameras. Oh, I'm so tired after 4 hours of talking.
I have a lot of questions, but of course I need to pass through the notebooks. Notebooks are perfect and very useful for me. Yeah, I will use it a lot.
Yeah, yeah. Feel
Thank
free
you.
to reuse it as you wish. I think that's by tomorrow I will ask you to play with the segmentation notebooks. And please find alternative data from mine. For example, it is Google data search, Google data search. Find another data. Try to just make your hands dirty with the data. For sure, code will be crashing in multiple places. So that's part of the. I mean, with the new data, that's because you will have to figure out. This will allow you to understand how this thing actually mechanically works. If you are not code person, you can do again the segmentation as I showed to you before in Power BI. And what's important, you should be able to do, you should extract the useful insights from the data, right? So with segmentation, it's a bit harder because segmentations are kind of one of building blocks. Nevertheless, I think that if you rerun some additional information, you will immediately see that, okay, these customers we can split on n segments, and here's why I believe they are actually different segments. For tomorrow we have planned one more churn exercise with our notebook. I will prepare for you the list of libraries which you should install. I mean, does everyone know how to use R, more or less? No.
No.
One. Okay, we may start with some basics of R tomorrow. I will show you how to use it, and we will then continue with the example itself. And I think that's actually R is like probably like usually people write R or Python. For last year, I think the Python is like a little bit winning R, but R is winning the Python in the way that it has much more things. It's much easier to use for people who is like new to the field, I think, as for me. So if you can just by tomorrow work with the segmentations. So if you prefer notebooks, and I think it's more beneficial for you, try to rerun your data within the notebook. If you don't like the notebooks, you can use Power BI and find the data. That's important things by yourself, like should be either from your business or from data analytics search, and try to segment customers. And let's talk, what did you get from it? It's not that complicated. So far we covered 4 segmentation techniques. Use at least 2 of them. Try to use more and compare what was your findings. And we will discuss it tomorrow in the morning. Then we will discuss some basics of R and how to install it. So we'll make a live session. And I will talk about churn in telco, which is in totally different methodologies and survival. Unfortunately, I think I will not have a chance to explain all the methodological background of that method, but if you wish, I can I can do it actually, but I think it's just not the purpose of this course to describe this methodology of more complex algorithms. But if you wish, I can actually explain it, or I can send you the materials up front so you can read it. Because I have some pretty extensive amount of slides over my teaching experience to a different complexity of teaching. So I can send you slides which are already summarizing all the stuff in a bit more technical way.
Yeah, please.
Yeah, sure. Would be happy to do it. So I will upload for you this methods slides so you can review them by tomorrow. And if you have questions, feel free to ask. I'm happy to explain it. I'm just afraid that I'm stealing your time from customer topic.
About the for segmentation techniques you mentioned.
Mm-hmm.
So you mean the K means, C means, DB scan. This is the for segmentation techniques.
Yeah. Yes. Yes.
Okay, so to play with segmentation, but not with churn rate for now, yeah?
With churn rate, not. We will finish it tomorrow, and then you will have one week by next weekend to play with churn. Okay.
Okay.
And what else? I think that's it from my side, unless you have some additional questions.
I just like to say thanks a lot, Lubomir. Yeah, just great content. Yeah, so and preparations with your slides and notebooks. Yeah.
Thank you. I'm happy to hear such a feedback. I'm still here to answer any questions you may may have. But I will start drinking something because talking 4 hours in a row is a kind of tough challenge.
Yeah. Some limoncello, yeah.
Yeah, some limoncello. I have this. I'm actually right now in the north of Italy in mountains for some. I mean, it's comfortable to work from here. So yeah, I should find some limoncello around.
Very good.
Yeah. Then good luck to everyone. Talk to you tomorrow. Have a nice rest of the day.
Thank you. Goodbye.
Thank you. Bye-bye.
Bye. Bye.
Thank you. See you tomorrow.
See you tomorrow. Bye.